Hey guys, welcome back. We got our e-learning lesson number 2. This is going to be something new. This is going to be something you haven't learned before. So this is new for all of us, the fact that you are learning it this way as opposed to being in a classroom. So uh, if you could please have a notebook out or something that you could write on where you could find it later, that would be great. Let's take a little bit of notes. So we have delta H, which stands for change in heat. If you remember from before, delta means change in. Back like when we did Q equals mc sub p delta T. Remember that delta T stood for change in temperature. Delta H is going to be change in heat, where H stands for heat. If delta H is negative, then the reaction is exothermic, and you are losing heat. So, for example, negative 457 kilojoules of energy. The reason why it's negative is heat's going out. If you remember exothermic, the words that sound like exothermic are exit or your ex, and those are things that you are out of. You're out of that relationship. You're out of that room. X means out. If delta H is going to be a positive, then the reaction is endothermic, and you are gaining heat. Heat's coming in, kind of like your bank account. If you're receiving money, then it's going to be a positive number, and that's what you're seeing over here. All right, so let's try a little bit of practice problems. Look, just like we're in school, all right? Same thing that we've been doing in the past. I got your equation up here, and I am a nice guy, and I already balanced it for you. You're going to use this equation for the next two problems. I want to know how much heat is released by burning 27.5 grams of CH4. And I'm going to do this first problem with you. All right, so let's go and try this out. All right, so our equation is up over here, same as what it was on the previous page. And this is my pre-done setup, so that way I don't have to spend time writing everything in front of you. Just like before, we are going to start with what you know. So if we look back at what we had, we know that we have 27.5 grams of CH4. It's always the same process. Start with what you know. Whatever's on a diagonal is the same. So we're going to start with what we know. So we got 27.5 grams of CH4. I'm going to put that over there. All right. And just like I was saying a moment ago, whatever unit is here is going to be the same unit that goes over here. So we got grams of CH4. Okay. Now, the unit, I'm going to leave some space here. The unit that's going to go over here is going to be moles of CH4. All right. Now, you guys have seen this plenty of times. When there's grams on one side and moles on another, you're going to do formula mass over here. So formula mass of CH4, if you have your periodic table, is going to be 1 carbon and 4 hydrogens added together. It's going to get you a total of 16.05 grams of CH4. Up over here, that's formula mass. What's formula mass equal to, guys? You know what it is. It's going to be 1 mole. All right. Let me go ahead and center this a little bit better for you. There you go. Okay. Now, because moles of CH4 is there, what's going to go down here? It's the same thing. Mole of CH4. But now here's the part that's different. Remember, this line means equals to. So whatever's down here has to equal what's up here, which is what you're seeing over here. Formula mass is equal to 1 mole. So for every 1 mole of CH4, I am going to produce negative 890.4 kilojoules of energy. That much energy is going out because it's exothermic, because it's negative. So every 1 mole of CH4, which you're seeing is right here, I'm going to make negative 890.4 kilojoules of energy. And the reason why I'm ending in kilojoules of energy is if we look back over here, I want to know how much heat is being released. The unit for heat is kilojoules. So by ending like this, we are ending in heat. We're ending in kilojoules. And it's further reinforced by the fact that there's an H there, H for heat. Okay? So now I need to multiply the top together. So I got to do 27.5 times 1 times negative 890.4. And I'm going to get out of that for the top negative 24,486. And it's just going to be unitless for right now. We're not going to worry about the unit. Going to do the same thing on the bottom, 16.05 times 1. Well, that's a pretty easy one, hopefully. Multiply those together, and you'll still have 16.05. All right? Take this and divide it by that, and you'll get your final answer. Your final answer is going to be 1,525.61 kilojoules of energy. Now, two things I want you to notice. First of all, you might be saying, hey, Mr. Mazur, what happened to that negative? Shouldn't there be a negative there? And kind of, yeah, technically that's true. But based on the way that this is worded with the English, it says, hey, how much heat is being released? If you say to someone something like that, how much heat is being released, you're going to be answering in a positive number. You're not going to say that it's releasing negative some amount, because that doesn't make grammatical kind of sense. So you're going to be saying it with a positive number. If you left it negative, I'm not going to mark you off. I'm just explaining why I'm writing it as a positive. All right. Where was I? Over here. So this is your final answer. That's how much heat is released. The second thing I want to point out to you is that if you logic this, it kind of makes some sense. 1 mole of CH4 produces negative 890.4 kilojoules. Our answer is more than that. All right. 1 mole of CH4 is 16.05 grams. So if I start with 27.5, so like a little bit less than double that amount, my heat that's lost should be a little bit less than double that amount. And hey, look, it is. And that makes sense, hopefully. All right. So now that I've done one, I want you to try out number 2. And I'm even going to try to give you some cool music to inspire you here as you do this. So go ahead and pause the video or keep it running, whatever you prefer, and go ahead and try out number 2. and welcome back. Hopefully you tried it out, and hopefully you got the right answer. So let's take a look and see. What I'd like you to do, compare against what I'm doing, and hopefully you got it right every step of the way. If you got it wrong at a certain point, then let's make sure it doesn't happen again. It's very valuable to know where you went wrong at what step. All right, so just like always, we are going to be starting with what we know. So we're going to be starting with 79.2 grams of O2. So let's type that into our equation up here. All right, so 79.2 grams of O2. All right, just like always, because there's grams of O2 there, you're going to do the same thing over here, grams of O2. And then we're going to do our unit up here, and it's going to follow that pattern that it usually is, where it's going to be moles of O2 over here. Whatever's down below has to equal what's up top. So every 1 mole of O2 is going to be equal to the formula mass of O2. Now, if you got your periodic table, that's going to be 32 grams of O2 because each oxygen is 16, and we got 2 oxygens. All right. Now, here's the part where I think if a person's going to go wrong, they are probably going to do it right here. Because moles of O2 is here, same thing goes here. That's not the part yet that I think people are going to do wrong. Here's the part I think people are going to do wrong. We're going to want to end with kilojoules over here. And if you put a 1 right here, you unfortunately did not do it correctly. The reason why is you got to look at your equation over here. It says that every 2 moles of O2, you get negative 890.4 kilojoules. So if you are someone who put a 2 here, congratulations, you did it right. Because every 2 moles of O2 is going to be equal to negative 890.4 kilojoules of energy. So you can't be a 1 because you needed 2 moles to get you that amount. And then from this point, it's just going to be the same process that you've already done. All right, let's multiply the top together. 79.2 times 1 times negative 890.4 is going to get you negative 70,519.68. And you are going to divide that by what's on the bottom, which is 32 times 2, which is going to be 64. Okay. And when you divide those two, you'll get your final answer, which is 1,101.87. Remember, we are keeping it positive because of the way the question is worded. It says how much heat is released. You're releasing a positive number. You can't really release a negative number. But if you left it negative, not the end of the world. And what's my unit going to be? It's going to be what was left over here at the start, kJ for kilojoules of energy. All right? That's how you do those sort of problems. I am going to post the worksheet that I want you to do, and you're going to do it in the same exact way where you take a photo of it after you're done, upload it. Seems like that's working for people. In addition to that, 2 other things I wanted to let you know about. Firstly, you are going to have a little quiz coming up for your next session, e-learning session number 3, whatever day that may be. So it's going to be on stoichiometry. It's going to be on this stuff, and it's going to be on the stuff that we've been doing before. Can you convert from grams to moles? Can you convert from grams of one substance into grams of another substance? That sort of thing. And lastly, I got maybe what is a special little treat for you guys. Here's a challenge question. Before all this started, I made this question because I thought that some students were doing so well at this sort of thing that I could write what is, in my opinion, the hardest question I could come up with using all the tools that I have taught you in the past. So we're talking about, I'm giving you a formula with a name. I'm not I'm giving you a chemical with a name. I'm not giving you a formula. I'm using the word diatomic. What does that mean? We're doing percent yields. I'm not providing you with an equation. In fact, I'm only providing you with half of an equation. And how can you fill out the rest? So this hits on a lot of skills that we've talked about. There's no extra credit or anything involved with this. I just thought that I would send this out now. And if you want to work on it and get back to me with the answer, you could send me the answer through email. I can give you a little shout out on our next recording. So good luck, and I will talk to you later.